Now we're going to look at the generation, toolpath generation. So what are the indicators for the length of time it takes to generate? Obviously, we talked about geometry, curves, surfaces, and mesh. That's going to affect your regenerating times. Your cutting parameters obviously going to affect that, and there's a few parameters we're going to look at it here in just a second, which are major contributions to the time it takes to generate a toolpath, as well as the machining preferences, and obviously your CAD system tolerance. Typically, your CAD system tolerance is set at 1,000th. At times, you may increase or decrease that. Probably wouldn't want to decrease it a lot less than that. But regardless of what it is, it contributes to the amount of information that's cooked into that surface. So it will add some time. It won't be a lot noticeable, but it does add some time. And then at the bottom here, we got some general toolpath generation tips. This is my little tip here I put in here. You can start with the default parameters. Joe mentioned with starting with a low density mesh. You can start with the default. Every toolpath you load, if you haven't ran it before, it'll start up with default parameters, and those parameters pretty much in all cases will generate a toolpath. So you can do a quick generation with the default parameters with your geometry just to verify that, yeah, I'm getting a toolpath. It was, regenerated pretty good. Let's go in and start, tinkering with that and getting it fine-tuned. And then also when to regenerate. Obviously, this is how you operate and how often you want to see your toolpath generated. But if you don't have to, you can generate, after you make changes. But on the other hand, if you're making a lot of changes, you may want to generate between changes. So at least you'll know, well, this change that I made, is causing an issue or not causing an issue. And then another thing that can affect toolpath generation is the type of tool you're using. Obviously, you're not going to base your machining tool based on your simulation. But if your simulation is taking a longer time, then, look at the tool type that you're using. Flat end mills are faster, ball mills are slower, tapered mills are even slower. And that just basically because of the way the tool is shaped and how the algorithms work generating the tool paths. Okay, so let's take a look at some parameters that will affect your toolpath generation. This dialog here on the right, the parameters that you see in here are the default parameters. So if you just bought the program, you installed it, and you opened up a horizontal roughing operation, you'll see these default parameters. Now, the two big ones that will contribute to toolpath generation time is your toolpath tolerance here at the top and your toolpath step over. Now, again, we're not recommending that you set these only to get a good simulation. It's just to reverse your thought pattern. So when you get into a simulation or a generation that you think is taking a long time, go back and look in at these two areas. These are the reasons why that it's taking as long as it's taking. The tolerance, just an example, you could reduce your tolerance by 50% and jack up your toolpath generation time by 25%. And these were tests that we performed just this week prior to the webinar. Again, toolpath step over. If you reduce your step over by 75%, you can increase your generation time by 40%. So it's just a way of looking at it. And then another area that can contribute to that is your cut pattern. The offset cut pattern is the fastest pattern. That and the linear, those are basically the same amount of time, depending also on your geometry, obviously. But if you went to an offset spiral, expect your generation time to double. If you go to a spiral, expect it to go double with even a little bit more than that. A radial, it jacks it up a lot. Only because on a radial, it works its way back and forth. When it gets to the end, it'll retract and go back and do it again. There's a lot of retracts, so there's a lot of time involved in a radial toolpath. But there's times when that's what you want to use, so just be aware of the generation time. And it's even faster than a high-speed toolpath, which has a lot of tangential motions in that path. So that's just an idea. It gives you an idea of what happens when you change these parameters, how it affects your toolpath generation time. And then also your CAM preferences, you want to take a look at those. The biggie here is if you have a multi-core processor, and most new computers now are multi-core. This particular computer has 4 cores, 4 coprocessors. You want to turn this option on for always generate toolpaths in multiple threads. I'll show you that in a minute, but that can decrease your generation time at least by 50%, probably more than that. And then above that, you have your part sampling resolution. By default, it's set to standard. And what this means is this is how many points across the surface it's going to sample in order to generate this toolpath. And as you know,
this I got to interrupt. Sorry, Don.
okay.
This part sampling resolution, it doesn't apply to all toolpath methods. It's only for 3-axis. I think it's only used in horizontal roughing and finishing and some of those types of methods. So so when if you're using a lot of those type of operations, these can have a significant effect on the setting can have a significant effect on your performance.
Mm-hmm.
But our general recommendation would be to keep it at standard. But if you have a very small part, let's say you're machining something less than an inch or so in size, then we would want to increase that to fine or medium or fine to get a better quality toolpath. But I guess Don is talking about the effect of the settings on this performance. So,
mm-hmm. And actually, Joe, in the tests that I performed, I didn't see a whole lot of decrease in time in going to the fine. It did some, but it wasn't like so drastic that I need to stay away from fine. But
yeah, it's a linear decrease, so it's not that significant. When I say linear, it's not quadratic or exponential. So you would see some decrease if it go to fine, but not too much.
Mm-hmm. And then at the top here, you can set your default operation tolerance for all of your operations, and that's set at 1,000 by default. Okay, let's show you a little bit about the things we just talked about for toolpath generation. We're going to go back over to RhinoCam, and then we're going to load this part model here. Okay, so here's the model that we showed on that graphic slide. And one of the things that we're going to show you is what happens when you tighten up your tolerance. Now, tolerance will affect how many, correct me if I'm wrong, Joe, but tolerance is going to affect how many sample points, how many motion points you're going to have in your 3-axis toolpath. So if you're running a path across a curved model like this, and you have a really tight tolerance, it's going to take longer to generate. So
yeah, that is the side effect of tightening the tolerance, because internally what happens is the geometry is, we internally, excuse me, in 3-axis toolpaths, internally NURB surfaces are converted linearized in some places. So when we do the linearization, the tolerance affects the linearization. And if the tighter the tolerance, the more data the system is using, that is the CAM system is using in its computation. So it results, like what Don is saying, is it does result in more toolpath points, but that's just a side effect. But the main effect is it's increasing the data being input into the CAM system.
Okay. And what I was going to do here is I was just going to go into the parallel finishing cut parameters. We have it set at half of a thousandth. I'm not going to tax it a whole lot, but I'm just going to set it at 0.1, which you probably would never use, but this is going to just show a baseline. And let's just generate that. Again, I apologize. I had a stopwatch I was going to use to do these, but that was so fast. Maybe, 4 seconds it generated that. Then go in, let's try 0.01. I'm not going to run it at 0.0005 only because I've got a lot of things running on the computer right now with the webinar and everything. So we're going to keep it within reason here. That was 10 times. So even that was pretty fast. You can tighten up even more. If you tighten up to half of a thousandth, it's probably going to take you 30 seconds to generate that, maybe a little bit more. So the next thing I wanted to show you was that, well, there's one thing here that I had that we didn't mention, and Joe, you had mentioned this to me just this previous week when we was going over this. The way the toolpaths are generated, based obviously on the geometry, but it's based on what geometry is visible on the screen. So if you have a lot, and obviously in support, we look at a lot of people's screens and we see how they work. And a lot of people have a lot of geometry on the screen that's not needed. So if you've got, keep your geometry separate, you probably got it already separated on layers. Turn those layers off that are not affecting what you're working on. That will increase your toolpath generation time. Just keep it clean, keep it simple, and keep it fast. So the next thing, I've got another part I want to load to show you one other thing here. And
one other note I want to make on the tolerance. Again, what tolerance to use, we run into that a lot with customers. That question, what tolerance to use, is really very similar to the question about what type of meshes should I be using. So again, using the right tolerance is very application based, and really you have to fine tune it, do a lot of experimentation yourself on the type of parts that you're machining, the size of parts you're machining, the material, as well as the machine tool that you're using. So there are a lot of factors that would determine the sweet spot, if you will, for the operation tolerance.
And also, we have a blog article on that toolpath accuracy. There's a host of other things you want to look at if you want to get that accuracy out to your machine tool. I recommend that you go and read that article on our blog. It goes through what you need to check, a checklist of things you need to do to get the accuracy that you're seeing on your computer out to your controller. So what I wanted to show you here was toolpath generation. We're still on toolpath generation. Let's go into the preferences. Let's go to machining. Now, you saw this. I mentioned that if you have a new computer, it's pretty much assured that it's multi-core. So that means that you have more than one central processing unit in the motherboard. And you can take advantage of that by making sure this checkbox is checked. It says always generate toolpaths in multiple threads. So I'm just going to give you an idea of how quick you can generate with that turned on. We're just going to right click on the setup. I probably have 30 operations and pick generate, and it's running them all in all 4 cores, and it gets through all of them in probably 4 or 5 seconds. Now, if I turn that off and run it, I'm not going to do it, but it will probably take a minute because it'll generate one and then it'll generate the next. It's just one operation generated at a time. So you want to have this turned on all the time.